Hey guys, welcome to Homework Help for Year 7, Term 3, Week 7. On page 15, we're doing set 4. Question 1. Find the value of the pronumerals in each of these correct to one decimal place where necessary. Okay, so it doesn't look like any Pythagorean triples that I can see here, so I'm just going to do k squared is equal to 7 squared plus 5 squared. So k squared is equal to 49 plus 25. So k squared is equal to 74. So therefore k is equal to the square root of 74. And you can use your calculator to get to one decimal place for this answer. Question B. Okay, so we know that, I'm just going to quickly show you this, x squared plus 8 squared is equal to 14 squared. Okay. Normally I would write out straight away that I can write out x squared is equal to 14 squared, take away 8 squared. But if you don't know that, you can do this first and then you can work to get to this. Okay, I kind of skipped that step. So anyway, x squared is equal to 196 plus, minus 64. Alright, and this is x squared, not x, sorry. So x squared is equal to 132. So therefore x is equal to the square root of 132, and get the answer with on your calculator with one decimal place. Now next one, let me see if I can do something here. Divide this by 3, I will get 12. Divide this by 3, I will get 5. 5, 12, this must be 13 straight away. This is what happens when you remember the Pythagorean triples. Alright, next one, question 2. A ladder of length 9 meters reaches up the side of the wall. So this one, we don't have any diagrams, so we're going to draw one. So imagine this is a wall. Whoops. Okay, this wall is 90 degrees. And you have a ladder that reaches up the wall. So this is your ladder. Okay, and it says a ladder of length 9 meters. So this ladder is 9 meters, and it reaches up the wall, reaches 7 meters up the side of the wall. So it reaches up from the ground to this height of 7 meters. All right, how far is the foot of the ladder from the base of the wall? So here's the base of the wall. How far is the foot of the ladder from the base of the wall? So what's this length here? X. So you have a triangle, right angle triangle. With this is 9, this is 7, and this is x. So to find x, we just do x squared is equal to 9 squared, take away 7 squared. X squared is equal to 81, take away 49. Sorry, this x squared. X squared is equal to 32. So therefore, x is equal to the square root of 32, and get the answer to one decimal place like they asked for. Question 3. The foot of a ladder is 3 meters from the base of a wall. So, okay, I'm going to copy paste this because I can't be bothered redrawing this. Okay, let's kind of shrink this down a bit as well. What the? Oh no, what have I done? What have I done? Okay. Alright, so we have this shape, and now the foot of a ladder is 3 meters from the base of the wall. So the foot of the ladder, this is 3. If the ladder reaches 14 meters up the wall, so this is no longer 7. Whoops. It's 14. Find correct to 2 decimal place the length of the ladder. So we're looking for, what is this length here? Call it x. So now all it did was just change the question around. Okay, so now you have the triangle. So x squared is equal to 3 squared plus 14 squared. So x, so you can work out what that is. I'm not going to do this. You can do that. So find out what x is. Correct it 2 decimal places. Question 4. Gary drove 22 kilometers due north. So he started from here and he drove to here. And this is in the north direction. 22 kilometers. Then turned and drove 120 kilometers due east. So he turned and he drove due east. So now this one will be 120. That's pretty far. Alright, how far is he from his starting point? Now because north and east are 90 degrees with each other, we can make a right angle triangle here. And we can work this out. We can say, alright, well, we want to find this distance x. Now this will be in whatever x is, will be in kilometers because everything else is in kilometers. So we can say that x squared is equal to 22 squared plus 120 squared. So x squared, I'm just going to give you, just do this one real quick. 14884. So therefore x is equal to the square root of 14,884, and you get the answer in kilometers. It says to how far is it from the stone? So just give it in to the nearest kilometers. That'll be fine. Alright. Question 5. A woman left home and drove 61 kilometers due south. So due south. So this will be 61. And then, let me see, 77 kilometers due west. 77 kilometers due west. So that's that direction. And then 25 kilometers due north. So south, west, and then north. And this one's only 25, so about here. Okay, then this is north. How far is the woman from the house? Okay, so I'm going to put this in blue. From here to here, what's the distance? Call that distance x. Now, we don't have a right angle triangle, but we can create one. We can say, actually, I'm just going to, instead of doing that, I'm just going to do the dotted line. Alright, so we know this is also 77, and we know, what's this distance here? We know that we know that this is 61 and this is 25. 61 take away 25, it's going to give you 36. So this length here must be 36. Okay, well, let's rub this out. Alright, so now we got this triangle, which is a right angle triangle. Now we want to find x. So let's see, what can we say? We can say x squared is equal to 36 squared plus 77 squared, and x squared is equal to, let me see, calculator, 7,225. So therefore x is equal to the square root of 7,225. And I'll give you this one. It's 85 kilometers. Everything else is in kilometers, so this must have been kilometers. Okay, that's that one. Next page. Find the value of x and y. X and y. Okay, so we can't find y first, but we can find x first because this triangle here. Let me see. Can I turn this into Pythagorean triples? If I divide this by maybe 3, I'll get 10. Divide this by 3, I'll divide it by 6. Divide by 6, I will get 5, and divide by 6, I get 3. 3, 4, 5 again. So 30, what I mean by this is 30 is equal to 6 times 5. And 18 is 6 times 3. So the last one must be 6 times 4. 3, 4, 5. Okay, 6 times 4 will give you 24. So therefore x must be 24. Got it. Now we're going to find y. So I'm going to redraw this triangle. Oh, this is a bad drawing. Okay. Now we know this is 18. Now this is y, and I want to find this distance here. This will be 24 plus 56. So 24 plus 56 will be 80. Okay, what's y? Let's see. We're gonna do. I'm gonna say y squared is equal to 18 squared plus 80 squared. So y squared is equal to 6,724. So y is equal to the square root of 6,724, and you work it out. Question 12. Let me see. Find the length of the diameter AC. ABC is inscribed in a circle with has been inscribed in a circle with center 0, center O with radius of 5. That means the radius is 5. Okay, so the radius is 5. These are all the radiuses. Alright. Now it says find the length of the diameter AC. Well, that's just double the radius, which is 10. Calculate the length of the chord BC. Okay, the chord BC. So that's 10. BC, which is this one here. Okay, so we have a right angle triangle. This is 10. This is 6, and this is x. Let's call that x. So we can say x. So I'm going to redraw the triangle. Something like this. 6x and 10. Oh, okay, I see. If I divide, I don't even have to work it out actually. If I divide this by 2, I get 3. Divide this by 2, I get 5. So this must be a 4. Okay. But it's not actually a 4. It's actually 4 times 2, which is 8. Because this is 5 times 2. Whoops. And this is 3 times 2. There you go. So therefore that has to be 8. So therefore x is equal to 8. All done. Question 13. The diagram shows a cone with a slant height of 1.13 meters and a perpendicular height of 1.12 meters. Find the length of the diameter of the base of the cone. Okay, so they want us to find the length of the diameter. But before we find the diameter, let's find the radius. Because we have a right angle triangle right here. And we have the units 113, 112, so you have a right angle triangle where this is 1.13, 1.12, and this is, let's call this R for radius. Okay, right angle triangle. So we say R squared is equal to 1.13 squared minus 1.12 squared. Let me see what that is. 1.13 squared minus 1.12 squared, and that's going to give us 0.0225. Great. So we square root of that. R is equal to the square root of 0.0225, and that's gonna, R is equal to 0.15. So we know that the radius is 0.15, therefore diameter must equal double of that, which is 0.3 meters. Done. Right, next one, question 14. ABCDE is a rectangular pyramid. The point F marks the center of the base. If EF equals 2 meters, Okay. You have to AD is equal to 3 meters and CD equals 12 meters. Find the length of FG. FG, if we have to find this length here. Now, do we have EG? Are we given EG? No. How are you going to find FG? Let me think. We have, this one is 12, this one is 3. Okay. This FG is going to be half of 3. When you draw a line there, this will cut it in half. Okay, half of 3 meters will be 1.5 meters. So therefore, this will be 1.5 meters. EG is this length here. So we know this is 1.5. We know this is 2. So what's that one? Okay, so we imagine you have a triangle. Right angle triangle here, where this is 1.5 meters and this is 2 meters. How do you find this length EG? So this is your EG. Well, we know that the length EG squared is equal to 2 squared plus 1.5 squared. EG is equal to the square root of whatever you get from there. Get the answer, and you can use a calculator to get the answer for EG. DG is let me rub this out. This is getting a bit messy here. DG. So what's this length here? Well, this length is half of 12. Okay, so that will equal to 6. And DE. Where's the this length here? What's this length? Well, if you can have a look here, that length, we can draw another right angle triangle here. Okay, so imagine if I take this side of this face and just draw it out here. Okay, draw it out like this. It looks something like this. Okay. Alright, so you have that triangle there. Whoops, I should change my... So we're looking for this length here, DE, I think, yes, DE. This is D, this is E. So looking for that length, which is the blue length here. Okay. Now to find DE, we know that we have a right angle triangle here. This is G. We already know what GE is, or EG. EG is from question B. Okay, if whatever that lists, we can use that. So, and then we have this one DG, which is 6. We need is 6, and we know whatever length this is, EG. So we can use Pythagoras to find out DE. So DE is here. So we can say DE squared, whoops, is equal to 6 squared plus with EG squared. So whatever you get for EG for question B, you can just square it up, add with 6 squared, and you get that. And then you just work out what DE is by square rooting all of that. Okay. And that is it, I think. Oh no, one more page. Okay. Extension questions. Okay, so here we got a farmer wishes to construct a fence around a paddock with the given dimensions. Find the value of X. Okay, not a problem. So imagine if I was to draw the complete rectangle there. Okay. What do we have here? We have, this is 70. This is 15. 70 minus 15. 70 minus 60. 55. This must be 55. So from here to here must be 55. Which means that this must be 55. Now, this is 70. This is 22. 70 minus 22. 70 minus 20 is 50. Minus 2 is 48. So this must be 48. There you go. You have a right angle triangle right here. Now we can use that to find x using Pythagoras. So I'm going to flip this triangle upside down for a little bit just to see it a bit easier. We know this is 48 and we know this is 55. Okay. Now to find x, I can say x squared is equal to 48 squared plus 55 squared. So x squared is equal to 5,329. So x is equal to the square root of 5,329, which equals to 73. So we found x, 73. Now it says calculate the perimeter of the paddock. The perimeter of the paddock, oh that's not too hard. So let me just rub all this. Oh, that's not a good idea. Okay. I wrote it on the wrong layer, so now I can't rub it out. Okay, not a problem. We know this is 73. Let me just redraw this in black. So that's 73. So to find the perimeter of the paddock, we just add up all the lengths together. You got 22 plus 73, 15, 70 and 70. So add them all together, you'll get the perimeter for the paddock. Determine the cost of fencing the paddock if fencing material costs $35 per meter. So whatever answer you get here, okay, this will be in meters. You just multiply that answer with 35. So this will be $35 times it by whatever answer you get there, and you get the total price. Done. Question 18. Okay. Peter and Robert left home at 2 p.m. Peter drove due north at 50 kilometers per hour, while Robert drove due east at 80 kilometers an hour. How far has each person traveled by 4:30? So they both left at 2, and at 4:30 they would have. That means that 2.5 hours have passed. Okay. So okay, let's find out how far Robert has traveled. Oh, actually, sorry. Let's find out how much Peter has traveled first. Let's do Peter first. Now, Peter is traveling at a speed. Let me see. Peter drove at a speed of 50 kilometers per hour, and he drove it for 2.5 hours, 2.5 hours. So to find his distance, we do 50 times 2.5. Just get the calculator if you want to, and just do 2.5 times 50. You're going to get 125 kilometers. Now let's look at Robert. Robert drove for 80 kilometers an hour and also drove for 2.5 hours. So the distance is equal to, by the way, that's an arrow. Okay, I just didn't draw it correctly. Okay, so that will be 80 times 2.5, and that will give you 200 kilometers. All right. Now it says find the distance between the men at 4:30 correct to the nearest kilometers. So we know that Peter traveled 125 kilometers. So from home, this will be 125. And Robert traveled 200. So this is 200. Okay, so to find x, we find a distance. Let's call this distance x. We can use Pythagoras. X squared is equal to 125 squared plus 200 squared. and you can work out x. X will be equal to the square root of all of that. So work it out. This is to the nearest kilometer. Question 19. A pencil case is in the shape of a rectangular prism. A pencil case in the shape of a rectangular prism has dimensions blah 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 blah. Find the length of the longest pencil that will fit completely within the pencil case. So here's your pencil case, and the longest pencil is going to fit diagonally. This is the longest length. So this is your pencil. Okay. So to find what length that is, we need to use Pythagoras. We need to find out this distance here. Okay. Now before we can find that distance, we need these two distances. Okay, so let's look at what this distance is. This is 8, right? There's 8. That must be 8 as well. Now this distance, I'm gonna call it. I'm gonna call this distance C. We don't have this distance yet, but we'll find out. Now to find the distance C, you can look at this triangle here, right angle triangle. Okay, I'm gonna redraw this triangle so you can see it. You got 12 here, and you have this distance here, which is 9. Okay, this will be 12. Whoops. This will be 12, and this is 9. This looks familiar. Let's divide this by 3. You're going to get 3. So 9 is equal to, let me just rewrite this. This is 9. This is 3 times 3. And let me put 12 in here. This is 12 divided by 3. You're going to get 3 times 4. 3, 4. This must be 3 times 5. So that's 15. So I can tell that that's 15. Okay, so now I have this other triangle. Let's look at this blue triangle. I'll color this in blue. Okay, so the blue triangle looks like this. And you have 15 and you have an 8. So we call this x. The longest side is x, so x squared is equal to 8 squared plus 15 squared, and then x is equal to the square root of all of that. So work on that and then square it and then do square root and get x, the answer for x, and that will be the answer for A. And that's your answer for question A. Now question B. If instead the dimensions of the pencil case are A centimeters, B and C, show that the length L of the longest pencil case that will fit inside the pencil case is given by L is equal to, wow, okay. Now what I'm going to do is I need space to do this working out, so I'm going to rub all of this stuff out. I'm going to redraw this. Now what I'm going to do is I'm going to move this down here. Right, I'm going to make this a bit bigger. Show that the length L, which is this one here, from here to here, just like what we had before, length L, of the longest pencil that will fit inside the pencil case is given by L is equal to the square root of A squared plus B squared plus C squared. Alright, so let's do this question again. Now with, instead of your 8, 9 and 12, we got A, B and C. Okay. Now what is this length here? This will be your B, isn't it? So I'm going to write B here. Okay. Now what, and this length is A. Okay. So what's this length? I'm going to call this, let me call this, let me put in blue. What is this length here? We need this length and we need this length to find L. Okay. So the bottom length here, we can say, well, let's call that length, I don't know, x. Okay, so x squared is equal to A squared plus B squared. All right, awesome. So instead of writing x squared, all right, I'm just gonna write here. This will be this will be, instead of writing, this will be x squared, right? Actually no, that'll just be length x. Okay, so x, actually I'll do it step by step so I don't confuse you. X is equal to the square root of a squared plus b squared. So x, so here's your length x, which is here, and that's equal to the square root of a squared plus b squared. Alright, now this length, I'm gonna put in green, this length here should be the same as this length, which is c. Okay, now using Pythagoras, I'm gonna redraw this triangle. So watch this, we'll redraw that triangle there. Okay, so all I did was redraw this triangle into here. Okay, now I know that the green one, this is C, this is the length C, this is a 90 degrees. Now the bottom length is the square root of a squared plus b squared. This is the bottom length there, and obviously this is your L, the length L. Show that L, okay? So now let's use Pythagoras. We can say that L squared is equal to C squared plus with this length of square root of A squared plus B squared, and then we square it, isn't it? I square this, and I will add them together, I'll get L squared. That's just Pythagoras theorem. Alright, so now L squared, I'm gonna write this in black now. So L squared is equal to C squared. Now what happens when you square something like this? Well, the square and the square root will cancel out, right? So all you're left with is A squared plus B squared. I don't know if you can see that clearly. There. Right. There you go. So, I mean, there's nothing in front of that, so we can just remove the brackets, and you have L squared is equal to C squared plus A squared plus B squared. Let's rearrange it. L squared is equal to A squared plus B squared plus C squared. So therefore, L is equal to the square root of A squared plus B squared plus C squared. And that is what they want you to show, to prove. And that's done. Okay, whoops. Done. Oh, that was a tricky one. Alright. Hope that helps.